Hi, Lindsay. So in this video, we're going to be starting our next chapter of sequences and series. First one we're going to take a look at here is the arithmetic sequences. So a sequence, as the definition, is an ordered list of numbers, as you can see an example right here. So an arithmetic, we're going to look at two different types in this unit. We're going to look at arithmetic, which we're going to look at today, and the other word is geometric. Okay, so an arithmetic sequence is a sequence of numbers that has a common difference. So this is going to be, you can see the difference between these numbers in order are all going to be the exact same. So we're going to determine if the following is an arithmetic sequence, and if it is, what is that common difference? So here we have each of these terms. So because this is the first term in the sequence of numbers, this is T1. This is our second term, so we can label this as T2, T3, T4, and T5. So we follow that pattern. So how do we go from 250 to 235? Well, we subtracted 15. How did we go from 235 to 220? We also subtracted 15. From 220 to 205, we subtracted 15, and 205 to 190, we also subtracted 15. So you can see this pattern here, that because we have this common difference, in this case it's negative 15, you could also have plus 15, and that's also perfectly fine. But when there's that addition or subtraction, that's when we have this arithmetic sequence. Okay, it's arithmetic. In this case, we can see that our first term here in this sequence is 250. So we're going to look at our equation in our next section here. But this first term that we signify as A is 250. And our common difference, which we use as the variable D, is equal to the value of this negative 15 in this case. So the general term Tn, okay, so n could be any integer, so is a formula that expresses any value in the sequence based on its position. So we call the first term A, and we use n to represent the nth term. So in this case, the first term has an n value equal to 2. The second term has an n value equal to 2. Sorry. The first term, n is equal to 1. Here now, n is equal to 2. Okay, and again, D represents the difference. So for an arithmetic sequence, okay, we always determine this first. Is it arithmetic or is it geometric? So when it's arithmetic, we will always have this equation. So T to the subscript n is equal to the initial term plus n minus 1 multiplied by D. So in this case, we're going to create our equation for our example above right here. So we saw that the A value is 250 and D was equal to minus 15. So if we were to put these into our equation, our T to the n is equal to A, which is 250, plus n is the variable that doesn't change, so that stays in there. And then our D value is equal to minus 15. Okay, D is at minus 15. So what we're going to do to simplify this is multiply this into both terms. So that T to the n is equal to 250 minus 15n plus 15. If we collect like terms with this and this, we're going to get our equation for any term in the sequence of 265 minus 15n. And some stipulations that we choose here is that n has to be the element of all integers. So the integers are every number that is greater than 0. Okay, so that n is greater than or equal to 1. We're not going to have a -1 term or even a 0. Okay, this right here, this 265. Okay, is that our 0 term, technically? What I would say to focus on is that, again, we're going to have positive numbers for this value of n, just to keep it simple. Okay, so that would be our general equation for this. This right here. Okay, so a recursive formula still has t to the n involved in it, but it's a formula that relates the general term n to the term that is before it. So when we do this n minus 1. So we want to find the recursive formula for the arithmetic sequence above. Okay, so in general, we have our equation. So let's see what we have here. So we have t1 is equal to 250. T to the 2 is equal to 235, which we can see is t1 minus 15. And then our t3 was equal to 220, which is the t2 minus 15. And it followed this pattern. Okay, so T4 is going to be the exact same. We take the term before it, and we subtract 15. And if we were to move on to T5, we take the term before it, and then we subtract 15. So in general, we also have this equation. We have t to the n is equal to t to the n minus 1, which is that term before it, plus the common difference. And in this case, our n value has to be greater than or equal to 2. So what we can say simply for our example is that t to the n is equal to t to the n minus 1. And since d is minus 15, we're going to put our difference just like that. So as long as we know that term before it, we can find out what t to the n is. Okay, so the next one we're going to take a look at is with this brand new example here. So for the following sequence, determine the general term, which is the equation for t to the n, the recursive formula, which is this what we have right here, knowing the one before it, and we're actually going to find the 24th term as well. Okay, we can predict that based off our pattern here. So what's going on with these numbers in the sequence here? So we're going from 2 to 5, which is plus 3. We're going from 5 to 8, which is plus 3. 8 to 11, plus 3, and so forth. So we can see this pattern that because we have an addition or multiplication, first of all, we can say we know that it is arithmetic. Okay, because it's either addition or subtraction here. So we know which equations we have to focus on now. Okay, so the first equation we have is a is equal to, so for the general term, t to the n is equal to a plus n minus 1 times d. So t to the n, a represents our initial term, which we have here is equal to 2, plus n minus 1. And the d here, this common difference, is going to be positive 3. We're going to take this, we're going to multiply it inside again. It's going to be 2 plus 3 to the n minus 3. And again, we can tidy this up. That t to the n is equal to 3n. We can collect this like term and this number here. So we have 3n minus 1. And in this case, we can put our condition that always stays the same, that n must be greater than or equal to 1. We're not going to have a 0 term. It's always going to be the first term. Okay, so here's our equation for the general term. So the next one we're going to look at is the recursive formula. So for part B, we have t to the n is equal to t to the n minus 1 plus d. And we're left with t to the n is equal to t to the n minus 1. And in this case, the difference is plus 3. So we have plus 3, and then we have n is greater than or equal to 2. So this here represents that recursive formula. As long as you know the one beforehand, again, we just add 3 to it to get to the one after. And the last one we're going to take a look at is, what is the 24th term here? So for this, we're going to use our general term here. So we're going to start off with that general equation of t to the n is equal to 3n minus 1. So in this case, for the 24th term, n is equal to 24. So we're going to have t to the 24. And in this case now, we're going to have 3 where we have this n. We're going to multiply by 24. And we're going to subtract 1. So this is going to give us 72, subtract 1. And t to the 24 is going to be 71. So if you continued this pattern and wrote it all out till the 24th term, you would get this number just right here. Okay, so this section, again, just so we looked at here, is all about patterns and sequences. Okay, let's take a look at the next one. So in this case, this example differs slightly. So we're given the first term, and we're given a general equation, and we want to determine the first 4 terms. Okay, then afterwards we're going to determine, is this an arithmetic sequence? So t1, we know to be equal to 2. Okay, so t2, so we can see here is what we want to find next. I'll use a different color. So everywhere that we have n, we're going to replace with that value of 2. Okay, so t2 is equal to 2t to the 2 minus 1 plus 2. So we can simplify this to 2t 2 minus 1 is 1 plus 2. And we know this t of 1 from our term beforehand. So this is going to be 2, that's in front here. t1 is also equal to 2 plus 2. And this is going to be 4 plus 2, which is going to be 6. Okay, so for t3, we're going to have 2t to the 3 minus 1 plus 3. So this is going to be 2t to the 2 plus 3. T to the 2 we just calculated. Let's actually fill this in right here too. T2 we know is from the one beforehand is 6. So we have 2 to the 6 plus 3. 2 times 6, sorry, is 12 plus 3 is 15. And if we do the last one, t to the 4, I'm going to squeeze that actually just right over here. Looking at our general equation, we have 2 to the t, instead of n now, we have it as 4 minus 1 plus 4. And 2 to the t3 plus 4. t3, which we got over here in green, was 15. And this is going to be 34. So our sequence of numbers is, we can write this over here, in the order that they'd appeared. So t1 is 2, 6, 15, and 34. So from 2 to 6, we added 4. From 6 to 15, we added 9. And from 15 to 34, we added 19. So this is definitely not an arithmetic sequence, okay? Because there's no common difference here. So what we can say This is not an arithmetic sequence because there is no common difference. Okay, so that's the indication that, again, it's not going to be arithmetic. So we want to determine in this last example here the number of terms in this sequence. So we go 3, 7, 11, 15, 19. There's a bit of a gap, and then we finish with our last term of 95. So first off, we can see, though, that we go 3 to 7. This is going to be plus 4. 7 to 11 is plus 4. 11 to 15 is plus 4. And 15 to 19 is plus 4. So this is, in fact, arithmetic. So we can use those general equations that we looked in our section today. So first thing we want to do to determine the number of terms is we want to find the equation for the general term. Okay, so remember our equation for that was t to the n is equal to a plus n minus 1 multiplied by d. So t to the n is equal to the first term, which we have here is 3, plus n minus 1, and the common difference here is positive 4. We're going to multiply this in, and we're going to get 3 plus 4n minus 4, and we can fully simplify this as 4n minus 1. Again, n is greater than or equal to 1. Okay, so in general, this gives us our equation. Okay, so what we do know is, okay, remember, this is T1, this was T2, this was T3, etc. So if we keep going, this 95 here represents that very last term of that t to the n. Okay, so what we can do next is that n is what we don't know. That's how many terms we have in this. We do know that t to the n is equal to 95. So what we can do is substitute this 95 into our general term equation and solve for n. So we have 95 is equal to 4n minus 1. We want to get rid of the 1 from this side. We add 1 here, add 1 here. We're just isolating for the variable now. So we get 96 is equal to 4n. We're going to divide this by 4 and divide this by 4 so that this and this cancel. And we are left with n is equal to 24. So what we can conclude is that there are 24 terms in this sequence.